So let's look at some more problems where we're trying to find these extrema on an interval. So find extrema of the function 2x minus 3x to the 2/3 power on the interval -1 to 3. So first step is to find the critical number. So take your derivative, f prime of x. So the derivative would be 2 minus, and then if I take the derivative there, I'll get 2x to the -1/3. So I can factor a 2 out here, and I'm left with 1 minus 1 over x to the 1/3. I'm going to rewrite it so it has a positive power. And then I'm going to get a common denominator. My common denominator would be x to the 1/3. And so this would be 2x to the 1/3 minus 1 over x to the 1/3. So there's my derivative. So now that I have my derivative, I can ask the question, what are my critical numbers? So first, I know that this function, this derivative, f prime of x, is undefined when x equals 0. I can't plug in 0 because it would make the denominator 0. And now I'm going to ask, when is f prime of x equal to 0? Well, the only way the derivative is 0 is if the numerator is equal to 0. And I'm going to solve x to the 1/3 equals 1. And if you cube both sides, I get the critical number 0. So f prime of x equals 0 when x equals 1. Now go back to your interval. Are these inside of my interval? If I look at my interval, it's -1 to 0. And both of these are inside of my interval. So here and here, these are both critical numbers. So then I'm going to plug in my critical numbers into my function. So remember what f of x is. F of x is 2x minus 3x to the 2/3. So you're going to plug in 0. You'll get 0. If you plug in 1, you'll get 2 minus 3, or -1. And now you need to plug in your two endpoints, which were -1 and 3. So if you plug in -1, well, this is I'm squaring. This means here I'm squaring and then taking the cube root. So when I square it, the negative will go away. So I'm getting -2 minus 3, or -5. If I plug in 3, I'll get 6 minus 3 times 3 to the 2/3, or 6 minus 3, the cube root of 9, which is we need to know what this is approximately equal to so that we can compare these numbers, -0.24. So now I'm going to take my four numbers here that I got out, and I'm going to compare, see which of these is the largest and which of these is the smallest. So the largest value is 0, and then the smallest value is -5. So our maximum is 0, and our minimum is -5. Let's look at one more of these problems, but now we're going to use we're going to look at a function with trig. functions in it. So find the extrema of the function f of x equals 2 sine x minus cosine of 2x on the interval 0 to 2 pi. Well, I'm going to need the derivative of f. That's what I'm going to start with. So f prime of x, the derivative of 2 sine x, that's going to be 2 cosine x. And then here, for cosine of 2x, you're going to have to use the chain rule. So the derivative will be, the derivative of cosine is a minus sine, so it'll become plus sine of 2x times the derivative of the inside, and the derivative of 2x is 2. So now we've got a little bit of, so the first thing I want to say is that this function f prime of x, it's always defined, it's never undefined. And I want to ultimately set this equal to 0 and find my other critical numbers. But I've got a little bit of a problem here because I've got x for that trig function, but for this trig function I've got 2x. So that's going to make it difficult for me to solve. So I'm going to use an identity here. The identity I'm going to use is that sine of 2x, it's 2 sine x cosine x. Okay, a double angle formula. So f prime of x will be 2 cosine x plus 2 times 2 sine x cosine x. So for my derivative, I'm getting 2 cosine x plus 4 sine x cosine x. I'm going to set that equal to 0. And I can factor out of both of these terms a 2 and a cosine x. So I'm going to be left with 1 plus 2 sine x. And now I'm going to split this off into my two solutions. 2 cosine x equals 0. Cosine x is 0. So what are my solutions to this equation in the interval 0 to 2 pi? X could be pi over 2 or 3 pi over 2. If I take 1 plus 2 sine x equal to 0 and solve, sine x will be negative 1/2. So my two solutions there, x could be 7 pi over 6 or 11 pi over 6. And so now I need to take these four numbers, this one, this one, this one, and this one, and then my two endpoints, which are 0 and 2 pi, and plug them all into my function. So go back to our original function, f of x. F of x was 2 sine x minus cosine of 2x. And you're going to plug in all of your values into your function. So plug in my endpoint 0 here. If you plug in 0, you'll get negative 1. If you plug in pi over 2, you'll get 2 sine pi over 2 minus cosine of pi. So 2 minus a negative 1. So I'm getting 3 back for this one. And you're going to continue on. So I'm just going to tell you what you get. If you plug in 7 pi over 6, you should be getting negative 3/2. 3 pi over 2, you should get negative 1. 11 pi over 6, you should be getting negative 3/2. And 2 pi will be negative 1. So you need to compare all 6 of these values. 1, 2, 3, 4, 5, 6. What is my largest value? My largest value is 3. So I'm going to say that the maximum is 3. What's my smallest value? My smallest value is negative 3/2. So the minimum is negative 3/2. And there's my max and my min.